Hello, I welcome you all. The problem reads the 200 kg crate rests on the ground, um, for which the coefficient of static and kinetic friction are 0.05 and zero point 0.4 respectively. The winch delivers a horizontal towing force T to its cable at A, which varies as shown in the graph. Determine the speed of the crate when T is equal to 4 seconds. Originally, the tension in the cable is 0. First, determine the force needed to begin moving the crate. So this problem is coming from the Engineering Mechanics Dynamics 13th edition by R.C. Hibbeler. Of course, we are able to solve this particular problem by using just merely equations of motions and kinematic equations. We are also able to use this solve this particular problem by using the equations principle of energy and work. And we are also able to solve this particular problem by using linear impulse and linear momentum. And since we are in chapter 15, we are using linear momentum and linear impulse. So to start with, let's draw the free body diagram. So let's section this cable there. We section it also here. We section it also there like so. So we are going to have the following. We'll have the tension force like so, there like so. We'll have the tension force there like so. We'll have the tension force there like so. Okay. So let's call this one here F. And of course we call this T, 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 T. And we do have also the weight of the box, and we have the normal force, and we do have some friction. Okay, so this one is the normal force, this is friction, this is W. So initially this box is static, it's just stationary, so we need to overcome this frictional static force before we move on to the kinetic friction force. So we need to calculate time at which this particular box will begin to move. Alright, so for us to do that, we'll need to apply the equations of equilibrium, because initially it's not moving, it's just stationary. So the summation, so let's say, let's find the time when the crate begins to move. Okay, so we'll say summation of forces. Let's find the y first. Okay, so of course we know that say MAY, but our AY is just equal to 0, and therefore we'll have N minus W equal to 0, and our N is just equal to W, right? And our W is just equal to 200 by 9.81. Alright, and then we have summation of forces in the X. Again here we just want to find the time, okay, when this particular object will begin to move, so it's not accelerating. Alright, so this just gives us F. We have F minus Fs minus Fs, so we can call this Fs now. Okay, equal to 0. And therefore, our Fs is just equal to Fs, which is just equal to mu s n, and our F is equal to 0.5 times n, and we just found n already. It's just 200 by 9.81. So let's find what this F is from this equation. So we know that F is just going to be equal to 2t, right? And you say F is 2t, right? Okay, and we know that t from the graph is just equal to 400 t to the power half, which we can write as 400 t to the power 0.5. Okay, so we have F, therefore this is just equal to we can simply say 2t therefore is equal to 0.5 by 200 by 9.81. Alright, so here we know that our t is equal to 400. I mean, it's already given there on top. So this becomes 2 by 400 t to the power 0.5 equal to this, like so. Okay, and then making t subject to formula, this we have a 0.5 by 200 by 9.81 divided by 800, then everything to the power 1 divided by 0.5. Therefore, t is just going to be equal to 0.5 by 200 by 9.81 divided by 800 to the power 1 divided by 0.5. So this gives us a 1.5037. Okay, let me check it. 0.5 by 200 by 9.81 divided by 800 to the power 2. Alright, 1.5037. So if we were to write this just becomes, let me check it, 2 by 400 by 1.5037 to the power 0.5. Alright, so we'll say the crate is at the verge of moving when t is equal to 1.5037 seconds. So once we found this, then we need to now find the final velocity, and we are using the principle of linear impulse and momentum. So say summation, since our force here is a function of t, so we need to integrate. So I initially would just been writing like this, remember? You remember? Okay, but since we are integrating, f is a function of t, so it will be integral, summation of the integral, summation of the force, then dt, then this is equal to m delta v. The delta v is just equal to v final minus v initial, where our v initial itself is equal to 0. So what do we have? So we are integrating from t0 to t, And then our F here, this is our coordinate system. So we are moving from, so we have F here minus, so this one we can now change it because our object has started moving. This is now kinetic, so minus Fk, which is kinetic Fk, then dt, this is equal to m F final minus this. Our T node is equal to 1.5037 and our T is equal to 4 seconds. Of course, M is equal to 200 and what else? F itself is equal to 2T and T is equal to 400 T to the power 0.5. And Fk is just equal to mu k n, and therefore our Fk is just equal to 0.4 by 200 by 9.81. Alright, so we have everything, so let's integrate. So we are starting from 1.537 to 4 of 2 times 400 T to the power 0.5 minus Fk, which is just 0.4 by 200 by 9.81 dt, and this is equal to m, which is just a 200 by v final minus 0. All right, so let's work it out. What do we have? So let's integrate. So this becomes, if we integrate it, so we have 2 by 400 to the power t. So this becomes 800 t to the power 1.5 divided by 1.5 minus 0.4 by 200 by 9.81. This becomes 784.8. We are evaluating this from 1.5037 to 4, and this is equal to 200 V final. V final, which is just equal to V, is therefore equal to, so let's calculate this. So we have 800 divided by 1.5 times 4 to the power 1.5 minus, okay, this one there's a t there, sorry, there's a t, okay, minus 784.8 times 4, okay, right, and then I will say minus 800 divided by 1.5 times 4 to the power 1.1 to the power times, not 4, times 1.5037 to the power 1.5, and then minus 784.8 times 1.5037. Okay, there we go. Okay. Alright. And then we divide this by 200. Then our V final, we get it as 6.62, and this is in meters per second. I need to repeat this. Okay, so 800 divided by 1.5, that's 533. So 533.3333 times 4. Sorry, 533 point. Okay, 533.3333 times t, which is a 4 to the power 1.5, right, minus 784.8 times 4, close brackets. Then we say minus again 533.333 times 1.5037 to the power 1.5 minus 784.8 times 1.5037, close brackets. Okay, and divided by 200. Yeah, so 6.62 meters per second. I think this is about it. We have found our final velocity. After t equal to 4 seconds. So I hope this particular video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye. See you in my next screencast.